The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.
If you're going to make a truck roll, making sure that it is maximally valuable. The worst case is diagnostic truck rolls. If you have to roll a truck out to site to figure out what the problem is, then you're going back to fix it later. You probably don't have the right replacement part. It's about making sure that the right people come to site. It depends on what needs to be done. So by the time you roll a truck to site, you should know that the issue cannot be resolved remotely. We'll touch on that as well. And that you're bringing the right person and the right part the first time. And that's super important.
Are you speeding the energy transition? Here at the Clean Power Hour, our hosts Tim Montague and John Weaver bring you the best in solar, batteries, and clean technologies every week. Want to go deeper into decarbonization? We do too. We're here to help you understand and command the commercial, residential, and utility solar, wind, and storage industries. So let's get to it. Together we can speed the energy transition.
Welcome to Supercharging Solar O&M with data-driven strategies for rapid growth. I'm Tim Montague, your host. I'm just thrilled to have Alex Nussey with Wattch and Trish Graf with Omnidian with us today as our expert panelists. And we're going to do a deep dive into how O&M is changing because of the advent of modern technologies like the platform that Wattch has developed. So I look forward to learning more about that platform. And you can type your questions into the Q&A or the chat. I think the Q&A is preferred. If that works, do that. And then we will answer those either on the fly or at the end at, say, quarter of. But we will get to your questions, and we really want to hear your questions. That's how you're going to get the most out of this webinar, is by asking us some questions. With that, I will let Alex Nussey introduce himself for the audience, please.
Yeah, absolutely. Thank you, Tim. Super excited to be here. And thank you, Trish, for joining. Really been looking forward to this for a while. My name is Alex Nussey. I mostly go by Nussey for those of you that have met me before. And I'm the co-founder and CEO of Wattch. Wattch is a monitoring, intelligence, and control platform for renewable energy. So solar energy storage, EV charging primarily. And we work very closely with O&M providers, both EPCs and dedicated O&M providers, to sort of help maintain the maximum performance on these assets. I guess that's my background in doing this for about 5 years now. As much as I do love listening to myself talk, I'm going to reiterate what Tim said. Please ask questions. Really want to make sure that we're sort of engaging with the audience. I think these things are always more fun when it's sort of a dialogue. So thank you.
Thank you, Alex. And Trish Graf.
Hi, Trish Graf, VP Sales and Strategic Partnerships at Omnidian. Omnidian is a technology-forward, data-driven operations and maintenance services company that provides performance assurance for our clients and partners on their PV assets and also their battery storage assets. So thrilled to be here as well. And likewise, please bring the questions forward.
Are your solar and storage assets performing at their peak? Some wait for failures or send technicians for costly diagnostics. But what if optimization was just a click away? Enter Wattch, the cutting-edge monitoring and controls platform. With Wattch, owners and operators can maximize their portfolio performance, avoid unnecessary site visits, boost production by up to 8%, all without expanding your team. Ready to supercharge your clean energy assets? Visit wattch.io and power up your efficiency today. Fantastic. Well, I'd love to give our audience a setting of the table. What is the state of monitoring and analytics when it comes to distributed generation, with an emphasis on C&I and small utility solar. So Alex, why don't you set the table a little bit, and then I also want to hear Omnidian's Trish Graf's comments on where is the industry and what are some of the challenges that the industry is facing?
That's a good question. I think that there's been so much focus for so long in the industry on the sort of leading edge of the growth curve. We're trying to get new assets on roofs and in the ground. And when I joined the industry, at least, it seemed like there wasn't as much attention on O&M, and at least especially not efficiency in O&M. But as these portfolios continue to grow and importantly start to age, it's really becoming a lot more important. And the kinds of problems that you could solve with sort of just man hours with a portfolio of 5 or 10 projects, it just doesn't hold up when you have a portfolio of hundreds of projects. I think you mentioned sort of C&I and small utility, we would say like DG scale, distributed generation scale. I think that's certainly where Wattch sees ourselves participating most heavily in the market. We do serve some utility scale customers, but the sort of core of our customers' portfolios is in that large commercial and industrial to small utility range. And I think that these are, actually, I think the right way to put it is any site that is not large enough to warrant full-time staff on site. If you're building a 0.5 gigawatt project, you probably have somebody there every hour that the sun is up. But that's not true with a distributed commercial portfolio. And that's where sort of the leverage of Trish used, the term data-driven and technology-enabled decision-making. I think it's where it becomes, it's not just sort of a nice to have, it's required to do a good job at maintaining the sort of the high bar in these assets. So I think our goal is to help the industry continue to scale without needing to scale headcount as quickly to maintain these growing portfolios. I could talk on that thread forever.
And just for some context, we installed, I think, something like 35 gigawatts of solar in the U.S. in 2023. And Trish, what is the scale of your business at Omnidian? You're one of the major O&M providers across the country in the DG space, but tell us a little bit about your portfolio and how you see the DG industry growing.
Yeah, and perfect dovetail off all the pieces that Alex brought forward is we're seeing a growth in DG for a couple of reasons. To bring back to your earlier point, Tim, is the IPPs, EPCs, owner-operators are looking to grow their megawatts. And large-scale utility-scale projects have their own set of challenges and issues, can take a longer time. So the shift to deploy for a utility-scale owner more DG has really been driven by the cycle can be quicker, right? We can get megawatts up faster. With that, as Alex said, the challenge is how do you resource? How a 500 megawatt solar, utility scale solar looks very different when you have 500 megawatts of DG. These projects are scattered nationwide. They're not large enough to warrant a full-time resource at that asset. And so what we've done in our offer and our focus is to support the fast growth scalability of large, scattered, dispersed DG portfolios so that anyone that's coming into the market can resource up quickly. If you've got an asset in Hawaii or one in Puerto Rico with Omnidian, it doesn't matter. We can support you immediately. So, and we're seeing that too, like with acquisitions, right? There's a lot of buying and selling happening in our space. And for an owner-operator, IPP, that's looking to acquire projects to help grow their portfolio, our goal then is to make that really simple for them so they don't have to add headcount to manage all those projects.
Yeah. So we've got this context of rapid growth and limited resources, human power, time, money, and we're trying to keep these assets performing optimally. We're trying to have an efficient machine to monitor and analyze the data coming out of the field. When do we need to roll a truck? When do we need to reboot an inverter? And it's just a big, hairy problem. And it's growing very fast. So when you guys think about these challenges that we've kind of put our finger on, and you, Alex, and your company are developing this kind of next generation platform for monitoring and analytics that will lead to better O&M, more productive operations. Tell us a little bit about how you see that landscape, and where are you really leaning in to, this piece of a data-driven O&M?
So I think that there's two sort of steps to maintaining this diverse portfolio like this. And the first is driven by the fact that not only are all of these assets sort of geographically, physically distributed, they're also very heterogeneous. None of them are the same. They all, especially when you have sort of a network of EPCs building for one owner, you're going to see different modules, different inverters, different everything at every one of these projects. And as they age, for these smaller projects, you probably don't have a strategic reserve of replacements. You're probably buying new parts that don't actually match. So now you have multiple brands at one site, 5 years in. So every project is unique from every other project in the portfolio, and they're scattered around. So the first step is getting a sort of single pane of glass, a bird's eye view over the whole portfolio that makes it easy to draw conclusions and analyze information very easily. And that's sort of what we see as our first responsibility, is get data from the field into the operator's hands in a way that is completely standardized. We call it our universal data model, but transform all the information as it's coming in, so that you can pivot on it as easily as possible. The second piece of that is finding sort of signal in the noise. We capture for a good size commercial, like a large commercial or industrial project, will capture something like 1 billion data points in a year from that site. And no human is going to go through and look at all of that data, right? So that's sort of where the machines step in to crunch that down and help you take the first step, tell you where to look, with the end goal of helping you identify as closely as possible precisely what changes could be made to improve performance, or what has happened to cause a reduction in performance. So from there, it comes the famously hard problem of the traveling salesman. How do you actually get to all of these sites? Who goes? When do they go? And that's not something that we are as involved in. But in terms of sort of, I think the intelligence piece is all about making it as easy as possible for operators to identify and size issues. Is this a $50 a day problem, or is this a $5,000 a day problem? It's sort of localizing that, and then making sure you know what you need to bring with you when you go out. Do you need a replacement part? Do you need this kind of personnel? What's the issue before you roll the truck? I'll stop there for a second.
Yeah, and Trish, I'm curious what Omnidian thinks about how assets are performing overall, and then what is the value add, right, when you onboard a more sophisticated platform like Wattch?
Yeah. So the first part of that is, our job as the custodian. I mean, we take care of our clients' assets as if they're our own, right? We measure ourselves on performance. So as Alex said, like, the components to really identifying that is the data that's coming out and the analytics that sit on top to help really sort through all the components and the noise. Is this really a problem that needs to be addressed? Is this affecting performance? Or is this something when you're starting a project, you need to take into account for your true expected energy, right? Where in the US is this project located? You need to account for weather and things like that. And then the second piece is, for us, it's, partnering and having a DAS provider, a data acquisition system such as Wattch, really makes our jobs easier. We act as an extension to our client's team, right? So we're technical asset performance managers, and having the right data with the right frequency, with the right components built in, really allows our platform. Then we have our own proprietary platform that sits on top of the Wattch data to further enhance the components of what is the actionable item that needs to happen here. Does it need to happen? does it justify, as Alex said, like if this is a $50 problem, but the cost to send a truck is going to be $1,000, the math doesn't work. And so we take the information from a provider such as Wattch, which has an amazing platform. Also, we have performance engineers that look at it to help determine how much of the performance is this affecting, to really consult with the client on what is the best choice for this asset and, your OpEx or the portfolio.
I think we like the word bionics here at Wattch. I think it's not totally machines. It's creating tools that help the right people who are actually doing the job, creating leverage. But bionics is one of our watchwords here. So
I remember in our pre-show discussion that I think of this in terms of dashboards and humans. And in a perfect world, the dashboard is greatly facilitating how humans then sort through the information coming in from the field and prioritize the information. And as much as possible, it's automating that for me and saying, okay, here's the greens, here's the yellows, and here's the reds. The reds are needing immediate attention, and that's your priority human in the DAS center or the NOC, right? And then they're deploying assets, whether that's remotely or boots on the ground, to fix the problem and get those reds to be greens. How do you guys see that, and how does Wattch facilitate that progression from bits and bytes coming from the field to a computer screen to a human army?
Human army, I like that. I think the separation where we at least draw our line of demarcation is we're really looking at the technical performance element. So if you have, a $500 problem and two $200 problems, or two $300 problems, but you can hit them both in one truck roll, maybe it actually makes sense to do that one instead, right? It's when you identify and size the problems, and I'll talk more about that in a second, but that's sort of where we start. And then it comes into the real world of humans and where they are today and what they're doing. That's where sort of managing the army is something that we work with fantastic folks like Omnidian on. For us, we think it's getting that green, yellow, red is our primary responsibility. And we kind of start with, Trish used the word expected production or expected energy. It's a common term in the industry. That's where we've spent a ton of our engineering resources is on developing this model. We call it digital twin, but you can call it whatever you'd like, to tell you what a system should be doing at any moment. And while there's a top line there, on a monthly basis, what should I be getting? There's also the drill down, which in my opinion is where the real utility starts to come from, is not just at the site level, not just at the inverter level, but getting down to every string on every MPPT of each inverter. Is an RSD failed? Can we detect that because the voltage in the string has gone down? Is this misconnected? Is there soiling, reducing the current? And we have a set of workflow tools within the product that help you sort of say, hey, look, at the top line, your site's only producing 95% of what it should be. All of that is attributable to one of these inverters, and it's actually an issue on strings 2 and 3. And then it's okay, go point at the right direction and tell you, start here. As for why that is, it's where the humans come in. Was it a mistake that didn't get caught at commissioning? Was there a hailstorm recently? And there's a fine line with any dashboarding tool between automated insights and then still giving the operator access to the raw data. You really want those to live side by side so that the operators know where to start, but then can jump in and look at as high fidelity information as they want, to sort of help draw those conclusions. I don't know if that actually answered your question, but
Trish, Omnidian is inheriting portfolios at various stages of their lifespan, from newly energized to have been around the block operating for some years. And then you're charged with improving performance, and you're actually guaranteeing performance at some level to your customers. But tell us a little bit, you've got some wonderful portfolios that are great examples of how big and hairy this problem is. Portfolios of 100 plus megawatts of DG projects that are spread over multiple states, and I don't cherish that responsibility. It's a massive responsibility that means real revenue potentially lost for your customers. Tell us a little bit about how Omnidian tackles this, and why did you onboard Wattch, and what is the end result that a customer can expect when they work with Omnidian with the benefit of Wattch underneath it?
Yep. So I'll take that in kind of chunks. You're exactly right. Taking on large portfolios of, as Alex said, no two are alike as far as, the components and the system type and size, scattered all over, different ages, different custodians too, Tim. So you may have a portion of the portfolio that was under great care and great watch, pun intended, and some that were not. And I think what starts with, when we're aligning with our partners, our clients around, our job is to, yes, ensure performance and increase performance. The first piece is aligning at, well, what do you expect this system to do now? And as Alex said, Wattch and Omnidian are very closely aligned on building a digital twin. We absolutely need to make sure we see your system as it's truly been designed and built. So it starts with, there's opportunities too, Tim, still definitely in the marketplace for these older projects to really kind of calibrate on what should it be doing. Good news is we get there. We have our performance verification tests that we do, systems online for 90 days. Sometimes that can create a lot of heartburn with their clients because they'll have had a number in mind about what this should be doing. And 90 to 120 days later, we're getting that actual real data on this is what it is. So worst case scenario, our calibration point happens after that performance verification testing. And then our commitment, as you mentioned, also with our performance guarantee, is that we've aligned on a number and we'll offer a 95% non-weather adjusted performance guarantee. No one else does it. Very different than an availability guarantee. So we're focused, that inherently drives our activity set and our focus on ensuring performance, right? The system can be available at 10 o'clock at night. It doesn't matter. It can't produce anything. So all of these components lead to setting up Omnidian as we are wholly driven, and we've got skin in the game now with a performance guarantee that we're going to work with you to ensure we're taking the right actions for the right problems that are really affecting performance. To go back to what Alex said earlier, there can be faults and alarms, and if you have somebody internally on the client side that's watching these, they're probably not trained like a performance engineer would be to understand what is this really affecting. We see a lot that without that the right data with the right analytics, and then as you said, Tim, the human who's then assessing all of that to determine, does this justify going out to make a change, a repair, a fix? You could be sending trucks every time a beep goes off and you are upside down pretty quickly. And so for that, with Wattch, what has been great for our partnerships with our shared clients is that we know from a data acquisition standpoint how they're grabbing the data, the different timestamps that they're grabbing it from, which components they're looking at. And as Alex said, string level information. All of that, those details help us do better on the performance end, on making the right decisions for the asset.
So there's three big buckets that we're talking about here: efficient resource allocation and prioritization, remote issue detection and diagnosis, and minimizing false alarms and missed problems. Alex, tell us about those buckets, and if you can give a real world example, that would be amazing. But how does Wattch see this world, and how does it come into play in the real world?
Yeah, it's definitely can talk about that. I think the three buckets you mentioned, I will let Trish mostly speak to number one, efficient resource allocation and prioritization. And I want to zoom out for a second. We didn't mention this up at the front, but I think that bucket two there, remote issue detection and diagnosis, is something where Omnidian and Wattch overlap. Omnidian obviously works with a lot of DAS providers. Wattch obviously works with a lot of O&M folks. I think we both really enjoy working with each other because we have this sort of shared ethos that makes it very high leverage when we have these shared clients, particularly high leverage. So that second bucket, remote issue detection and diagnostics, is something that we sort of have, especially the back half of that, the diagnosis. We have some overlap in. I will touch on a couple of real world examples here. I think we see issues come up in sites two times. They're sort of in the ongoing operation, which is what everyone thinks about, the new problems that emerge. And then there's commissioning, making sure that Trish used the phrase as built, making sure that your as built is actually what was as built, especially in commercial. Getting a authoritative representation of what was installed on site and how it was installed can sometimes be a painful process, but it's essential in order to right size expectations with the long-term owner. So I'll start a little bit, couple of real world examples. And if you don't mind sharing those slides I sent you, I'd show a couple of different items from that.
Sure.
The
slide one is on screen
slide.
now.
Cool. Yeah. So if you don't mind jumping to the third slide there.
Okay.
It's my little face, actually. Yeah. So this is just one of the ways, this is an example of a sort of scorecard that Wattch provides for an inverter. So we look at it at the very top level. We have the overall health score, as we call it, that actual versus expected or actual versus ideal energy. So this inverter is very healthy. And we sort of analyze an inverter in three stages, mostly by looking at the DC inputs from that photovoltaic array. So the first is, and I realize you can't see my mouse, but I'm looking at this first table here, the sort of ideal versus measured voltage. And this is a great example of sort of automating steps for human users to help give them the most leverage possible. So that measured voltage column is an average of the input voltage on each of the strings for that inverter over the course of a day. And then that ideal voltage is what our digital twin says the voltage should be. This takes into account a number of calculations. We're looking at the irradiance at the pyranometer. We're transposing that onto the array. We use the IV curve of the module and its pan file, and we essentially simulate what its voltage should be. And then when we compare those, we can see that they very roughly match. Now, if you go down one slide, you'll see here's an example of another inverter where they don't match. In this case, in MPPTs 4 and 5, looks like we basically swapped those two strings. And in this case, that actually has a pretty minimal, you can see 96% health score in the top, minimal impact. But depending on how those are switched and how many you've put on each string, it can have a material impact on the overall site performance. And this is something that within 10 or 20 minutes of turning the site on, you can come look at this and make sure that you have strung the project correctly. This is something that we really encourage owners to use as part of acceptance when they're sort of taking over the project. And this is just one of those kind of analytical workflows that I mentioned. We take the raw data in, and that's that measured voltage. We augment it with simulations from our digital twin, and we give a sort of rough-sized conclusion to the operator using the product. We have that final column there. Length mismatch is basically how far off we think the strings are and from being wired correctly. Now, the owner then has to make a decision on whether or not it is worth fixing. And that's sort of the next step. But it is our goal to put these conclusions, within 5 minutes. Don't need a lot of data to run these analytics. We can sort of, in a very automated fashion, tell you whether what got installed actually matches the as-built drawings that you received. And from here, you fix enough small problems, even at 1 or 2%. This inverter is performing at 96%. It adds up, and across the board, on average, you can get some pretty material gains. We see for our customer base for commercial and DG scale about 8% gain for people that start using these tools to commission and then in an ongoing fashion maintain their sites.
Let me ask you a couple of questions here. So if you're looking at a site, you're sitting in a knock and you've got some flags on sites, and then you're drilling into the site and looking at a more granular level. I immediately am concerned that the number of assets involved is very large. And so is Wattch, though, filtering through this information and helping the human at the knock level know where to drill down, or is it simply just flagging sites and then it's up to the human to determine priorities?
Yeah, so, and I'll actually dovetail. I think I can see somebody put in the chat here. I was looking at the questions that I see in the chat. Faults versus alerts. So I think we think there's kind of two stages to performance management. The one that's hardest is when you're bringing the sites on for the first time. It's that like right sizing of expectations. I'll talk about that in a second. In the steady state, it should really be push more than pull. Our product will tell you when there's an issue. If you have everything performing well, then we're constantly watching every 10 seconds as data flows in from each site. We're looking at that data and reassessing whether or not it's still healthy. And if it is not, we can create an alert, a notification for the user. And that says, hey, maybe go take a look at this. In terms of prioritization, if we have the financial implication of performance at that site set up, we can actually rank those basically by estimated daily or monthly cost. So how much is this in dollars going to impact the customer? Whether or not you make a resolution step comes down to how much it's going to cost you. And that's where it is, where my trucks are, where my boots are. And that's sort of outside of the scope of our product. But the cost that it is causing is something. So we go from healthy asset, enters an unhealthy state, create an alert so that the user sends an email, sends a text message, whatever it is, so that the user knows to go check on it. And that's when we enter one of these workflows where it's like, okay, there's underperformance. We know how much it costs. Let's narrow in on why. But that's after sort of we've already created this notification and rough prioritization for the user. The more painful side is when you onboard a new portfolio. You bring in 50 sites, 100 sites, and a lot of the time in Wattch, when we do that with, especially in CNI, it's all red. It's all Fs and Ds. And it's that conversation of, some of these are older assets. They have a lot of subcritical issues that, anyone can catch when an inverter fails. But if you have an MPPT that's coming in and out, most inverters, most monitoring products won't flag that kind of problem. But all of that adds up, and across the board, you can have a pretty unhealthy portfolio. And then it's the conversation of, these are 10-year-old assets. Does it make sense to go spend the money to bring these? They're at 70%. It might be 2/3 of the, you might be able to get to 95 in a third of the cost. And then it's another 2/3 to get to 100. Is that worth it? How do I want to set my expectation? And that's the most time-consuming part, I think, and setting, expectation setting can be a little sensitive.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 3-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes 3-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more. Heller asks a good question. What part do diagnostics, faults, and alerts play in the O&M data collection, and which are the best? And I guess I'm curious how Omnidian thinks about these things, because you're really on the receiving end of this.
Yeah. So it's also too, it's the nomenclature, right? So it's to some of our clients, an alert and a fault can be like the same thing. And that lies where we step in and Wattch steps in, is depending on how you have your DAS set up, you could get 1,000 alerts a day. And no one human has correct. And a lot of it is, I don't want to say noise, but most often noise. And so it's the ability to have the analytics or the AI and the ML that sit in there to really sift through. And as Alex said, having that front end financial information to also really purge through, well, what pieces matter to the ROI, right? And analyzing the root cause of the issues and having the right data and the right analytics and the right performance people and team to look at it is really, to me, the cherry on top, so to speak, so that you can determine, all right, we're going to filter out these temporary conditions. Shading is a good example. Oh, it's underperforming. Is it? Oh, it went back up. It went down. It went up. Why? Well, one, there's nothing to do about shading other than if it's depending on why, right? Is it another building coming into play or something? Or are they alerts that don't require intervention? So these systems can be very finicky and very noisy. And what the Wattch platform does, and then what the Omnidian platform does is get rid of the things that don't require to send someone out. What can we do remotely to potentially, that's always our first step, is what can we do remotely to address the situation? Our goal always is to reduce, minimize, eliminate the OpEx costs of sending a truck out there. And we've proven it on, 500 megawatt portfolio. Tim, an interesting statistic is that the industry benchmark for truck rolls per megawatt is 6 truck rolls per megawatt. Your numbers, your business case is going to be upside down pretty quickly.
Over what period of time? When you say six truck rolls per megawatt?
I think the data that we used was 12 to 48 months.
Okay.
But we then even truncated it to, let's look at just 12 months. If the industry benchmark is for the 5-year life of an asset is 6 truck rolls per megawatt,
mm-hmm.
What is Omnidian's participation in reducing that? And let's even just say the first year it's under our custodianship. And we were able to reduce that by over 2/3. And that's because, this is our wheelhouse, right? So with the right data and the right analytics and the right performance team looking at it, it is, don't send a truck every time. Send it only when when it's necessary to really make, as Alex said, an impact on the financials. And I think we're going to get there later on in the conversation. But Alex knows this, Tim, you probably know, I'm sure you know this as well. That number has to come down. It can't be 6 truck rolls a megawatt. There's no way the financials on these assets are going to work out long term. And there's a labor shortage. We haven't even touched on that yet. From a technician standpoint, there's a labor shortage on the qualified expertise that is required to go and do these repairs. Like I said, I think we'll get there a little bit later, but there's lots you can do early on in a project to avoid all of that activity and going to the site.
Yeah, I guess it really boils down to 2 things: improving performance and reducing the cost of O&M. Those 2 levers are going to push asset ownership in the right direction, right? This is good for the bottom line of the asset owner. So let's drill down though a little bit more about, let's assume, okay, for a second, that you have good construction, that the project got off on the right foot. That's not always the case, certainly.
Can I go live in that world?
Yes.
And maybe you can comment on, what percent of projects get off on the right foot. But then there's going to be degradation over time. Things happen. Connections come loose. Equipment breaks. Shading happens. Maybe there's not proper vegetation management. Maybe there's a dust storm and there needs to be eyes on getting a cleaning done. But what does Wattch allow Omnidian to do that moves the ball down the field?
I think it's about how should I say, if you're going to make a truck roll, making sure that it is maximally valuable. If you The worst case is diagnostic truck rolls. If you have to roll a truck out to site to figure out what the problem is, then you're going back to fix it later. You probably don't have the right replacement part. It's about making sure that the right people come to site. Depends on what needs to be done. So by the time you roll a truck to site, you should know that the issue cannot be resolved remotely. I'll touch on that as well. And that you're bringing the right person in the right part the first time. And that's super important. In terms of remote capabilities, I think that is getting better. Wattch, we call ourselves a hybrid SCADA platform over a DAS platform because we have our tagline is, bringing the sophistication of utility scale SCADA to an ease of use and price point that works for commercial and DG scale solar. So we want to bring as many of those remote control capabilities that exist in the high end projects down to these lower end projects as well. So whenever possible, if you can complete a task remotely, let's do that before you go out to site. Whether that's clearing a fault, resetting an inverter, reclosing a main breaker, reconfiguring an inverter if you installed the new one and forgot to change a setting. There's a lot that can be done remotely these days. IV testing is a new one. We now have looks like 2 of the major brands support remote IV testing, and we support that in Wattch. So instead of sending somebody out for a day to IV test each string, let's just click and grab that data from every inverter while I'm sitting in my nice air-conditioned office. And if I figure out that some of my RSDs are broken or my combiner boxes, we can go ahead and get that new part ordered before you make the truck roll. So I think bringing it back together, step 1, do everything we can remotely, full control over the project. Wattch enables control for all the assets that support it, and that list is improving. And then the second is authoritatively identifying the problem, so that you don't have to make nuisance truck rolls. You don't have to make diagnostic truck rolls. You can just go out and actually fix the problem, walk directly to the right place on site, and make the change. But Tim, did that answer your question?
Yeah, that's good. So we have a question from the audience. What is the market standard for performance guarantee? And do you see the market catching up to an Omnidian's 95%? Can it go any higher?
Oh, great question. And I want to put a piece out there just for some context. Is I have a utility scale wind background, and so what I see are lessons learned. Same thing in wind, where these projects, lots of different parts, lots of different OEMs and different standards, and how are we taking care of them? What data is important? So lessons learned, even though completely different technology, much different scale and size. I want to preface kind of how I'm going to put forward these next components with that. So we saw in that older industry, which still not old, still growing, it started with availability guarantees, right? I will guarantee, we see that in solar as well, I will guarantee your asset is available 95%. Sounds really compelling, right? Except for it doesn't matter much in wind if that asset is available when it's low wind season. Same with solar. It doesn't matter if that asset's available when it's 10 p.m., 9 p.m., 8 p.m. at night. So we've seen a shift with, there are performance guarantees. We're not the only one that does a performance guarantee. We are the only one that takes the weather equation out. And I'll say that, I'll package it shortly, is we assume the weather risk. We have over 2 billion data points. Think of it as an insurance actuarial. We're managing our risk on how is weather going to impact the performance of that system. When we have enough data to support, we'll take that on. So there might be another provider out there confirming they'll do a 95% performance guarantee. Challenge is, what are the carve-outs, right? What's excluded? Not just weather, what is excluded, what we really are trying to change the industry to focus on the right behaviors to get these assets performing. And so we say, we'll take on that weather risk. soiling, shading, snow. Like, we're accounting for all of that. We're going to confirm you're going to get 95% non-weather adjusted, and we'll work towards that together. If not, we have a financial reimbursement. We have to pay back per kilowatt. How much did we miss? We owe you money. To circle that back, I think the industry is still maturing as far as guarantees go. But again, if I take my lessons learned from wind, it's just shifting and it's moving. And Tim, it all starts with, if you want to guarantee performance, you have to work up the chain. The right parts, the right construction, the right as-built, the right digital twin, like everything has to start upstream. And that's ultimately our goal, is to focus on how do we participate in making this really a renewable energy source that can be really financially attractive. So
I love this question. What kinds of things can you actually see and fix remotely? And one of the contexts here is, I think it was Trish's comment that, there aren't enough technicians in the world to service our now growing portfolio of solar assets. So this remote monitoring and diagnosis is extremely important. But what kinds of problems can we effectively identify remotely? And either one or both of you can answer that.
Yeah, I'll take the first pass. I tried to dovetail that question a little bit in my last answer, but I think just to rattle off, it changes a bit by component. For inverters, they're getting better, but just resetting them still clears a lot of issues with modern string inverters. Like, that shouldn't have to happen, but it does. So just being able to reset an inverter can clear a lot of issues. So depending on your sort of, generally in the industry, we hear DAS to mean read only and SCADA to mean sort of read write to the site. If you have that SCADA capability, you can reset inverters. You can, how do you say, like main breakers and reclosers. Most sites at that size are going to have SCADA. It might be very expensive, but you can reset that depending on the allowed operating parameters from the utility. Same goes for arc faults on inverters, reset those. And then where things get really interesting is running sort of mutative diagnostics. So an IV curve test is a great example. You can't gain that information from an inverter while it's operating normally. You have to put it in a special operating mode, have it sweep over the input voltage range and capture that data. And that's a task that normally would need to be completed on site. You de-energize the inverter, plug in a piece of test equipment. But if you can control that inverter remotely, you can just coach it through running that same test all remotely. And that helps you have one additional piece of information before you go out to site. So the answer is, depending on if something fails, it can't be resolved remotely, obviously. But any problem that can be resolved without a physical action on site, let's do that. And then if we do have to go in and change something physically on site, then let's know exactly what it is by introspecting, tweaking as much as possible before we go out there. Another good example is like waveform captures. If you have a power quality meter, a lot of these revenue grade meters these days are actually very smart. You can poke at them and say, hey, capture me a waveform so I can see exactly what's going on site, hold that remotely, one less step to do in person. So I think that's the sort of the high end, is solve some problems and diagnose almost all others. Really want to know what's wrong before you go out there. Trish, do you have anything you want to add on that?
No, it's kind of what I'll put forward is really a culmination of the conversation we've already had. Is it starts upstream. First of all, like, are you getting? We could talk about, we remote diagnose 75% of the problems. Well, Tim, and the reason is because we've gotten, they're not really problems. You have to sift through that first layer first, right? So that's the opportunity where a Wattch comes in and partner with Omnidian with our AI and ML, is to, those 6 truck rolls per megawatt are because the intelligence, the data, the analytics, the performance engineer those eyes aren't on that asset. You're sent, every time you see something, you're sending it. As Alex said, components are continuously improving. Things, are getting better. We can see more. That's the piece is, not operating in the dark. And then understanding, well, I think it's for me, and I think it aligns with Alex as well. It's less about remote diagnostics, I think, again, as nomenclature, and it's more about, well, which problems really warrant a truck to roll.
Yeah, it doesn't. I think we're moving away from, I think historically there were two types of projects. There are projects that got a truck roll for every single fault code that any inverter threw, and those were all underwater. And there were the projects that got no O&M whatsoever. And, those may have actually been more profitable, even though they were finding out their issues 3 months later. Yep. And the right answer is like somewhere in the middle. We're using the words fault and alert. When at Wattch, when we say fault, we mean a piece of hardware, usually an inverter, but also any kind of device, sort of self-reporting an issue, fan fault, arc fault, things like that. For a long time, that was how people looked at the health of a site, is by tracking down faults. A lot of tools create an alert, which is a notification for every fault. That's crazy. A lot of these sites generate thousands of faults a month. We think of it sort of completely backwards, which is let's actually analyze the performance from a first principles perspective. And this is something we share with Omnidian. And then we can go look at fault codes to help understand why. But if, you have a fault code that isn't going to, there's also this idea of like preventative maintenance. If a fault code indicates that something is going to die, that's also important to know. But we should not be spending human capital on every single little fault code. It's about creating the right alerting rule set so that you only get alerts for high signal events.
So as asset owners and developers are adding more storage into their solar projects, either initially or retrofitting in storage, does that change the game at all from a data collection point of view or the way that data is collected from these sites?
Yeah, batteries. I love batteries. I will throw one from Omnidian first, which is that this idea of availability versus performance gets much worse with batteries, because and a battery can be available for 95% of the year and only make 5% of the revenue. Like some of these batteries, the leverage on that peak demand event, or if you miss one sort of demand spike for a behind the meter battery, you can be underwater for the whole month of the whole year. So this like separation between availability and actual sort of financial performance just gets wider. So you have to take the same lessons and then do even better in the storage world. Would you agree with that, Trish, my characterization there? 1,000%.
Yeah. If that battery isn't performing when you need it on whether you're following a curve demand or whatnot, the entire project is upside down.
Yes.
You need it to be available, performing. You need it to be performing, ready to roll when those demand spikes go up.
Yes.
So,
yeah, and I think storage we talk about solar plus storage. They're getting married together, but when we talk about the health of a battery, it's very different than the health of a solar farm. In some senses, it's actually easier to measure. If you charge the thing up all the way and empty it, and it charges and discharges at the right rate to the right total capacity, that's a pretty good assessment of health. The weather doesn't really play into it in terms of sort of the electrical health of the system. What makes it so difficult in solar is divorcing the weather piece and understanding sort of the weather adjusted. Has it just been a cloudy month, or do I have problems? I think to answer your actual question about data collection, yes, I think right now most solar monitoring tools will pull in a data point or two from storage. They'll give you a meter, or they'll give you a top level state of charge, but they're just not designed for a truly sort of multi-asset solution. Wattch had the advantage of being a relatively new business in the monitoring space, and we from day one said this is a multi-asset product, and sort of batteries have been baked into our data model from the very beginning. And being able to pull, there's also way more data from an average energy storage system than there is from a solar system. So being ready to capture all of that and present it in a unified and intelligent way, incredibly important. And it's something that I think is going to be a big wake-up call in the industry as people start wanting higher storage attachment rates. Residential does not have this problem, for whatever it's worth, because it's all these like walled garden ecosystems. But the larger IPPs won't want to be trapped in any one OEM's sort of software ecosystem. So they'll have to be open data standards. And there are, but getting all that information into one place today is a huge gap. And I think it's something that we're able to solve well for our customers. And the demand for that is really only increasing. And it's one of the things I like talking to the Omnidian folks the most about is like, where do you see this? Because I think solar's still growing up compared to wind. I mean, storage, I feel like, is so nascent in terms of these kinds of questions. So it's exciting to work with other people that are thinking hard about what the future 1 year, 5 years, 10 years out is going to look like.
We've got one more question from the audience that we should get to, and we're down to the wire here. But so thank you all for being here. Really appreciate your participation. How do asset owners measure the costs and benefits of third-party O&M? How do they make that decision whether or not to hire an Omnidian or to conduct all that activity themselves?
To me, it's not a complex formula. It really depends. We Alex knows, and I know, we know several IPPs that self-perform. But what makes that business case work is they have clusters of DG portfolios near their utility scale portfolios. So they've been really strategic. If they're going to self-perform, they've been really strategic about the geography. We can use our team that's at this 150 megawatt site to go also service these other 50 megawatts within a 100-mile radius. A lot of it comes down to, it's headcount. So one, it's the technicians. Depending on your portfolio, to me, it's pretty simple. It should be geography driven, because as we talked about very early on, if you have an in-house team of say 10, 20, even 30 technicians, are you going to set up regional hubs? You could, you might, right? You might have a regional hub in the Northeast, a regional hub in the Southwest to take care of those assets. What we're seeing with distributed generation, what we continue to see is scattered portfolios. It typically doesn't pencil out to have your technicians in-house. You may have technical asset managers in-house, and they are true partners of ours as well, that you have folks in-house that are responsible for the performance of those assets. But I might be overshooting here, but the only time I have seen an asset owner self-perform is when they have had a large enough portfolio in a very condensed region to justify having their own technicians.
I mean, this is a little outside of our direct scope, but I completely agree with everything Trish said. I think it's an opportunity cost of where you want to develop. Like, I think it's maybe self-performing, you can make a case that it's less expensive, but you are trading this opportunity cost of sort of being constrained geographically. And I think there's different business strategies. And we'll see in the long run. I think there'll probably be successful people doing both. There already are. But
Are your solar and storage assets performing at their peak? Some wait for failures or send technicians for costly diagnostics. But what if optimization was just a click away? Enter Wattch, the cutting-edge monitoring and controls platform. With Wattch, owners and operators can maximize their portfolio performance, avoid unnecessary site visits, boost production by up to 8%, all without expanding your team. Ready to supercharge your clean energy assets? Visit wattch.io and power up your efficiency today. Well, hopefully we've left our audience with some additional questions, and I would like the panelists to please let our audience know, how can the audience and listeners to this recording find you online or in the real world? Trish, you want to go first?
Sure. Trish Graf at Omnidian, and my email is tgraf, Graf, @omnidian.com. Can probably leave it somewhere in the chat, so I will put that in there. Just Nussey was quicker to it.
I just dropped you in there. Did I get that right? That's my email address. Yeah. I will make the same plug I did at the end of the podcast, Tim, which is that we say we're connecting tomorrow's grid. I also love connecting with the people that make tomorrow's grids work. We are a very sort of feedback-driven product organization. If you have ideas, thoughts, criticism, whatever it is, I would love to hear it and have a conversation with you about it. I think everyone talking about how to build a better renewables industry is the way that we move the ball forward. So I'll be at SPI, come find me, RE+, and that's my email. Shoot us, reach out. Love to have the conversation and hear what you're thinking about the space.
Likewise, the entire Omnidian team will be at RE+. Please look out and find us.
Great. And you can check out all of our content at cleanpowerhour.com. Give us a rating and a review on Apple or Spotify, and reach out to me on LinkedIn. I love hearing from my listeners, or you can contact me via the website. I want to thank Trish Graf with Omnidian and Alex Nussey with Wattch for joining us for this webinar today. I'm Tim Montague. Let's grow solar and storage. Take care, everybody.
Thanks, Tim. Cheers.
The Clean Power Hour is brought to you by CPS America, the maker of North America's #1 three-phase string inverter, with over 6 gigawatts shipped in the U.S. The CPS America product lineup includes three-phase string inverters ranging from 25 to 275 kW. Their flagship inverter, the CPS 250-275, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. The 250-275 pairs well with CPS America's exceptional data communication, controls, and energy storage solutions. Go to chintpowersystems.com to find out more.